Hello, and welcome to this tutorial on a technique called circle packing. In this video, I'm going to explain what circle packing is, and I'm going to show a couple of methods of achieving this in TouchDesigner using chops and GLSL. We're going to look at higher level components that create the circle packing for us, and we're going to specifically look at how we can make cool art with these outputs, particularly using something called a replicator. And here is kind of an example of two systems where I'm using a replication method to place unique systems within these circles. We're not going to look at directly recreating both of these outputs. I'm going to show you how to use this technique to basically create your own setup where you have multiple circles packed into a space that each has its own unique output inside. Before we start working with TouchDesigner, I wanted to show you a bit of the background of what circle packing looks like in code, just so we have an idea of the logic. This is a processing sketch. It's fairly simple, and in this sketch we're going to basically pack circles together. I'm going to move this over to this side of the screen, and we can see here that all the circles on the screen are not overlapping in any way. Sometimes their edges might touch, but they're not overlapping. There's no crossover. And so basically what we're saying here is every time we create a circle, we're checking against all of the other circles to see if there's an overlap. And if there is an overlap, we are not introducing that circle. In this logic here, we can move this little mouse activated thing around, and we can see that as I overlap, we change color. And so this is the boundary mechanism that will allow us to check if there is a collision. And also, if I press the spacebar, we can see all of these circles that essentially were created and not used because they didn't meet that condition. Let's try turning up the amount that we want to add to our system, say 100 circles. We can see there's lots more. It's harder to find a place that isn't attached to a circle. And we can see that there's a lot of circles here that didn't meet that criteria. And this is partly why we have things like max tries. So we don't go on forever and ever to keep adding circles when we might not get to our desired circle amount. Let's try pushing this up even further one final time, and let's see what we get here. And we can see that it's kind of at a point it's sort of diminishing returns. I could also kind of add in my max tries to 10,000. And now we can see that as we play around with these mechanics, it takes longer to generate, but we have more circles on the screen that are packed. It looks more dense. And if we visualize what wasn't added in, we can see it's nearly now a whole field of color just because we have so much stuff that wasn't added and was added to this other array. And it gets really slow. So this is the effect that we're going to try and recreate in TouchDesigner. The demo of this processing code will also be available on the Patreon, available with some of the other project files. Some quick kind of cool elements of circle packing that I wanted to show you, and what kind of got me interested in circle packing was these little things called diatoms, which are essentially kind of tiny microorganisms. And if we look at them under a microscope, they look super cool. And sort of in Victorian times, people would arrange them in these funky patterns. So they would arrange things into circles where there's no overlapping. Nowadays, this can be done digitally, but it's an effect I really like. And I actually, kind of early on, before I got into working with TouchDesigner, I would kind of recreate these effects as kind of a method of collaging things. And all the imagery here was generated with fairly early AI kind of DALL-E. This was like DALL-E 1 before it got actually good. And this was basically, I think every image was 256 by 256 pixels. And so I kind of tried to generate these AI diatoms. I then built a processing script that cut out the background, and then I could arrange them into a sort of a circle packed grid using that logic. This is a larger circle packing of just circles. In terms for if you want to find some other resources for learning about circle packing, particularly GLSL, I would recommend taking a look at No One's Image, and he has a really great GLSL tutorial on circle packing. I will show a version of a circle packing GLSL component that I've been working on that I will share on my Patreon, and you can get a bit of a background on how that works by watching that video if you're interested in learning about some of the underlying logic of how this might work in GLSL versus in Codeland. Okay, that's enough build up. I'm going to start going through these components and building some cool network stuff now. Okay, here we are in a simpler, more bare bones setup, and here I have two components. One does circle packing using chops and scripts, and one is using GLSL and gives you a more sort of animated version of this circle packing effect. What I want to do is show you how to take this data and basically have each of these circles encapsulating its own specific sort of system using a replicator. In this kind of effect, we could make something that looks more akin to these diatom slides. But before we do that, I'm going to give you a bit of a lowdown on what these components do in terms of the controls. So here we have the number that we're going to try and achieve. We can control the maximum radius. This is going to be how big can the maximum object be and how small can the smallest object be. You could have things that are really big and then you kind of end up with just a few of these outputs. But normally if you kind of go for a mix between large and small, you're going to get a fairly good layout. This is the number of tries. I have it fairly low, but you could put it up, and as you saw in my processing version earlier, at a point you get to a sort of diminish of returns where you don't get that many extra circles added, and it takes a lot of extra computational power to get essentially the same effect. So I'd recommend having this fairly low so the effect comes fairly quickly, but doesn't suffer too much in terms of its overall speed. We also have this thing called the C switch. So right now it's basically mapped in a square, sort of a grid. If we press 1, it's going to have a kind of more a circular output. So it's going to basically try and crop that into something that is sort of more of a circle. So it has a circular edge. Obviously, it's not going to be a perfect bounded circle, but we'll see the difference between this C switch 1 and 2. Or sorry, 0 and 1. And if we go to 2, it's kind of the same effect, but with the interior missing. So you have the outside of that circle. So this is something that is kind of fun to play around with. If we pulse, we create a different variant of that mapping. And the one other thing I wanted to mention is right now we can see that there's quite a bit of data here that isn't doing anything. This basically means that there been no condition met. What you can do is it outputs the number of active samples. So we can see that there's 40 active samples. And basically we can either trim this. I should have done this in the chop, but I didn't. We can either trim this, or in the instance of replicators, we only want to create 40 that are active versus the extra 30 that are inactive. And this just allows us to do this a bit more elegantly. Okay, this is working in GLSL, and this is a version that is kind of inspired by the No One's Image tutorial. In this instance though, it's a pixel shader versus a compute shader, and I've made some other changes that make it usable for me on an M1 Mac computer. In terms of the controls on the shader, we have our growth rate. So that's basically how fast we grow. If I turn on this wireframe here, you can see that as I turn up that growth rate, we have more overlaps. So turning that down is going to give us a more effective circle packing output. We have our resolution here, which is linked to this constant. So If I turn this down to 10 by 10, we're going to get less circle particles drawn, which will be useful for us for when we start using the replicators. And we also have effects like the U width and the U height. So basically this is how wide and how tall our system will be. So this could be if you're working in different types of dimensions. You can see that that's scaled it there. Let's maybe bring up the number so we can see that better. So this can be really effective too, and this is maybe more useful for creating sort of different types of animations versus using this as a instancing tool. This is obviously also instance. We can see that we have all this data has been used to basically control a system of circles, and we could take this and move it into something for our replicators too. We're going to start off by disabling this, and we're going to use our circle packing multi to work with replicators. Okay, I'm going to add my replicator here. And for those of you that haven't worked with replicators before, basically a replicator is a method of copying something multiple times. So we can see here, if I make this nice and big, I have my replicator. It's referencing a base module, and it's basically copying that module multiple times. And so once I set the number of replications, it's copying all of those versions as many times as I set, and this is going to link to how many circle positions are generated by my circle packing. So it's a really useful way of copying things that you want to sort of be generative in some way and have lots of different outputs. Right now I'm just going to leave this here because we actually have to make something that we want to use. And for me, before I actually encapsulate that in a base, I'm just going to work with my network on this level before starting to put things in containers. So let's create a circle. I'm going to plug that into a geo. And what I want to do is just start out bringing in some of the logic here. And this is going to change later. But basically, I want to reference this chop. So I'm going to say pos. For my circle, I want to access the first index of that chop on the X, Y, Z data. So to do that, I'm going to say op pos. No, actually, I'm going to call it cpos. So I'm going to say op cpos. I want to access the X channel, and I want to access the 0 index of that X channel. And that's giving me my size. So I'm going to copy that into here. And I also want to translate that to its correct X, Y position. So I can just copy this, and I'll say, you know what? I messed up here. I want to do size. That makes a lot more sense. And then I want to do X, and I want to do Y. The useful thing about when we actually start replicating this is we actually will then create some automatic methods for indexing where all these circles should be positioned and what sizes they should be. But for now, we're just working with the one. What I want to do now is I want to create a render. And this is something that we will keep outside of this encapsulated network that we build. This is going to be our main render for the system. So I'll create a camera and a constant for my circle, just so that we can see that it is clear on the screen. I'm going to change my resolution to 1280 by 1280. I'm also going to move my camera in a little bit. Okay, if we want to, we could go and just see the whole range of this system. Okay, so that's pretty well scaled. Okay. And I'll visualize this here. What I want to do is I now want to create some kind of particle system that's going to be placed within that circle. So that this becomes just an outline, I'm going to go to my constant, I'm going to go to wireframe and turn on topology wireframe just so I have this circle. And to create a particle that will be placed inside that, I'm going to say add convert, and I'll also plug that into a geo. For add, I will turn on add points, and for convert, I will say particles per point. I want to give this system some kind of value of particles for positions. So let's say, take this noise, I'm going to make it 32-bit RGBA. I'm going to turn monochrome off. I just want a few particles here, so I'm just going to say 5 by 5. I'm going to run that into a null in case I have to do anything with that. And I'm going to turn on instancing in my Geo2. So translate R and G, and let's turn on, or let's add a point sprite. And let's turn that up. Okay, so what we can see right now is that our points are massively away from where we actually want them to be. And that's fine, we're going to figure that out in a second. But for the time being, let's play with our actual noise values. So I'm going to scale these down. Let's do like 0.02. And rather than sort of moving them in this transform section, I'm going to drag everything out and I'm going to add in a point transform. And I want to access, in the translate for that point transform, I want to access the first parameter as we did before. So I could write it all in, or I could copy it from the reference that we have correctly done. So I'm just going to start off with my X and my 0 index. Basically what we're referencing here when we make these coordinate checks is we have 3 channels. We have X, Y, and Z. So this channel here is going to be either X in these little quotations or 0 because it's the 0 channel, the first channel. I find it easier just to reference the name. And if we were to access a different index, basically this is the first channel and the first index, so this value here. If I was to go in and access, say, the 61st value, we know that's going to be 0. So we can see that basically this is going to let us access any of these data points in this setup. If I go above, we see we have 71 samples. Let's say I go way above that, go to 100. We're going to get an error because there is actually no data here for us to reference. In this case, let's just go back to position 0. I'm going to copy that and add my Y. I'm also going to bring the offset down, and ideally that should be right in the center there, so potentially I made an error with my circle referencing. Let's take a look. Yeah, make sure to reference the X and the Y. Okay, now that circle moves down and our noise is right in the middle. Let's do a little abs time dot seconds, do 0.2, and let's see how far we can push this. It's a bit big. An easier way of making sure this kind of fits directly in that center is we have a size variable, right? So we have this radius. So let's take that in noise, and for the amplitude, let's take our size for that first output. We can see that it is a little over, so let's go like this, copy it again, put it in brackets, what we want it to look like is this. So we want the original size minus the size divided by 2, and this should fit nicely inside our circle. I'm going to turn down my point spray, and I'm also going to add in a little trail effect, just so that we have something that is a bit more sort of interesting. I'm going to do texture 3D. I want it to be just 12 in the trail. And I'm going to turn down my point spray a little more there. Okay. So for now, this is good. We could obviously go in and add more sort of funky controls, but we'll look at that later once we've replicated this. What I want to do now is I want to encapsulate all of this by selecting the network, this section of the network from the circle to the point sprite and the geos. I'm going to right click and I'm going to say collapse selected. And we're going to have an error. And that's okay, because we're going to go in and resolve all these errors. We're going to zoom in to the base component. I'm just going to rename it. I want it to be called something followed by a 0. So I'm going to just call it circ 0. And the value is very important because we're going to use the parent value to basically act as our index. So circ 0. So what we want to do to start linking these to the chop that's in the outside parent is we have to preface all of these parameters by parent in brackets 2 dot op. And let's just keep doing that. It might be worth copying it. Parent 2 dot. And we just add this to the beginning of all of these references that we have created. We'll go there in a second. This translate. And this cpos and cpos. Looks like there's a little error there, so let's see where I've made the error. Okay, we've got to put in the brackets. And there. Okay. This can be a little confusing because it is kind of hard to write and see text in these little expression windows, but bear with it and you can get it right. I'm also going to be sharing these files in my Patreon, so you can have this as a blueprint if that is helpful. So this is really cool. We still have to make one more update though, and this is because basically we're referencing index 0. So this is basically always going to give us whatever position 0 is. So it's always going to give us the same thing. So when we replicate this, it's going to replicate that a lot of times, but it's just going to be in the same position. Oops. Home that. So what we want to do is where we have our indexes is we're going to say parent, open brackets. I'm just going to drag this out. Parent, open brackets, dot digits. Right now, this is going to look the same, right? Because we're referencing still channel 0. The digits on the parent are whatever this second value is. But let's just say I create a constant, just so we have something to play with here. I'm going to encapsulate that. I'm going to say base 16. And so it takes that value that's in the parent and it feeds that through. So when we replicate all of these objects, that value is going to be super, super important to basically tell us what index that we want to use. I'm going to copy this parent.digits, and we want to fill all of these index declarations here with parent.digits. Same for the center. So let's check digits, 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 digits. Very good. For the noise, we're going to do that as well. making sure everything is nice and linked. We're going to do this for the point transform. And I think that is it. We're not making any changes to that geo. Okay. So now this should be kind of good to go. Obviously our render cannot see the geos inside that object. So what we're going to do is we're going to attempt to relink those. So we're going to use pattern matching for when we get more objects, and we might have to change this name depending on what we change our multiple objects to. So circ underscore star. So that's our first bit. It's going to say any object called circ, and the star is basically going to be any value following that. And then we also want to do geo star, because we have two geos, right? We want all those geos. So now we can see that we have linked that in. If we create more of these, see how it populates that and moves our circ to that new position, and it actually renders that. So that's great. Just going to close that. Okay, so what we want to do now is we've made this great first step of actually making a blueprint. This is basically the blueprint that we're going to replicate many, many times. In fact, we're going to replicate it 40 times. I'm going to actually split my screen at this point and turn off this background display so it's a bit easier for me to work as things get a bit more complicated. Okay, and what I want to do is I'm going to move this replicator down just to arrange my screen a little bit better. I'm going to arrange things like this. And what I'm going to do now is give an overview of what the replicator component does and how we can use it. So in the replicator component, we have a few things. We have this replication method. So how do we replicate? Do we use a table or do we use just a number? In this case, we're going to use a number, and we want this to be the active circles. I'm just going to call that active circs. So I'm going to drag that onto my replicator. Number of replicants, active circs. We're going to start at 1 just because we've already generated our circ 0. And let's say that we want to underscore there, just because that is going to give us the same convention. Basically, it's going to be operator prefix is basically whatever we name it. So it's going to be circ underscore followed by a value. Just to be safe, I'm just going to say -1 because obviously we've already got our first circle value. So we want 39 circle values on top of that that will make us up to 40. Okay. The final thing we have to do is we have to give this a master operator. This is basically the operator that is going to be the base for everything. So basically this operator will be cloned 39 times. To do that, I'm going to take this circ component that we built and I'm going to drag that into master operator. And we can see that it has now populated all of our circs, which is really great. Let's add in, let's just see what happens if we add in that 40. Yeah, I guess that works. Amazing. So we now have this system. Other things that we can do in this replicator is we can, for example, change the layout. So we can have it all horizontal, all vertical, and we can change the layout position. So you can move things closer or further away to certain points. I'm going to stick with grid, and I'm going to move it down a little bit and over here, because it can be quite visually distracting. Obviously we can hit X key and then we lose some of those extra connections if we toggle that on and off. The updates that I'm going to make to this now are I want to add in something that's going to pulse this recreate all operators. I can just do a keyboard in, And so that's going to pulse whenever I make a change to my master operator, which I'm also going to color pink so I know that it is easily accessible when I want to make changes. And let's try and make some changes here. We have our noise, and we can see that basically the noise is scaled here, but basically we have the same noise seed for everything. So what I want to do is I want to have my seed change based on what parent I'm in. So I'm going to say parent dot digits, our old friend. I'm going to recreate that, and we should see, if we go in, that that seed is now 10. So we have a bit of change, but it's not that drastic. So we can start thinking about parameters either internally or externally that might control these different noises. We could have a noise inside that controls everything, or we could have a noise outside. And often this is sort of a way I like to go, so I can kind of have external control of all of these operators versus something that I have to kind of instance in here. So I'll show you how we would do that. I'm going to create a noise, and let's see what we actually want to control. I'm just going to view this outside just so we see. I want to control the period, and I want to control, that's already controlled. I mainly want to just control the period. Okay, so let's link in to our noise length, and let's make sure it's in samples, not in seconds, that we have these 40 values. I'm going to turn down this period, so it's basically a separate channel for each one. And then I am going to delete this because that was just a reference. Let's call this noise control. So for period, I'm going to say parent2.op noise CTL. What have I called that channel? That's important. Let's actually name it something. Let's call it NV. Let's just say noise value. That's what it stands for. NV parent dot digits. And I've done something wrong here, so let's see. I've got to close this up. Let's try that again. And let's go a bit more crazy on this amplitude here. That's not making that much difference. Let's add in another channel, and this is going to be res. Okay, so our range here is like 0 to 5. Let's bring this in, and we'll do something a bit more funky with this. So we can just take that value that we just fed in. So for the period, we'll take that, we'll go to our res. What we want to do is encapsulate this, and this is getting really messy now, but bear with me. We'll encapsulate this in an int, and let's say times by 10. Okay, so now that's looking better. We have these different resolutions in our chops, and we can see that some of them are more sort of noisy in the sense that they're nice and we can say they're more noisy in the sense that they're nice and kind of fluid, and some are more just sort of abstract noise. But now if I feed this up, we can play around with that a little more. And obviously, as with many noise things, we could actually automate this on the outside. Although this might have some repercussions for the type of particles that we're doing in terms of the resolution. So it might be worthwhile having a separate value or a separate noise for our res. So I'll remove this and I'll remove that and turn off this TZ. So right now this is kind of me just experimenting with this network. For the res, I'm going to just say it was 2, right? Noise CDL2. And we want res. Okay. And we also want to do this for both of these axes. So that was something I missed out on. Okay. Now things are getting a little slower. So we can maybe also just think about bringing this amount down as well. So 61, let's do 220. And let's play with these values too, so it's not moving quite so much. So now we have this sort of method that we can control things with. So we have a fairly neat effect here. Let's go and just play with the camera a little bit just so we can kind of zoom around and just see some stuff. So we can see that like these particle systems are fairly like detailed once we get in. Some of them are just a little busier than others. A few things that we could do to sort of just make this more, you know, just generally interesting is let's keep on with that constant. Let's have it as a matte background, and let's just try putting in another noise, and let's just set that offset. Actually 0.5 is good. We'll have like a super high period, and we can just copy this into here, and we'll just kind of put that onto the constant. You can see one is already in play. We've got lots that are sort of very granular. I'm just going to be really, really hacky about this and just move the Z. So we can see that we have this single one that's linked just up a little bit. So now these should be on top of that that constant. In terms of actually wanting to bring out things that we could then like mix together or perform post-production effects on, right now we're bringing out all the geos. So we just actually want to do geo 1, and then we'll do geo 2. So then we have both of these as things we could actually comp together. I'm going to create an output. And let's do an RGB key as things that we could kind of comp together. One of the issues we're getting is some of these values here that we're sending from this noise select 2 are quite wild. So if I pull this down a little bit, we should get something that is a bit more sort of manageable. We could also play with that offset to sort of bring things up a little bit, create more particles, or kind of just bring it down. That's kind of nice. And I'm going to play around with this period too. Let's see if we can get anything cool. Okay, there we go. So that's going to be manipulating the... Okay, there we go. Okay, so I've sped that up a little bit, and I'm also going to turn down this period a little bit. And so now we get these sort of more like these sort of bloom type effects as things kind of push and pop into existence. For sort of post-production-y type stuff, what I might do is I would probably add a little bloom on here, sort of play around. Actually, you know what? Instead of the bloom, I'm going to add in a blur and a screen. And then I'm going to composite those together. If I pull up that blur, we get a sort of a glowy effect. You could also add in elements like feedback. For the time being, I'm going to keep it as is, and I'm going to just play a little bit more with these settings. So what I kind of want to do is change this bleed size. So I could have things that are like going to be bigger or much smaller. So that's just going to be the center there. So what I'm going to do is I'm going to add in a parameter here where we can control that second size, basically parameterize that. I'm going to add in a pattern chop, and I'll just call this noise CTL3. That's going to be our third noise control. We're going to take this value to our length. So we have 31 values on our length. Right now we have a sign, and what I want to do is random non-repeating integers. And so right now this is going from 0 to 1. I'm going to change this, so I want it to go from 1 to, let's say, 4. And now what I can do is, I'm going to just take that name, copy that, and again our little bit of scripting here is going to get really long and crazy. But so instead of parent.digits divided by 4, what we're going to do is keep that parent.digits, because that's going to be our index. We're going to say op noise control 3, the 0 channel, I forgot what I named it. Let's see if I'm missing something here. Okay, after a little bit of faffing around, I realized that I made a pretty silly mistake, partly because it's just hard to read this. But basically I needed to reference parent2, because obviously parent brackets is our current parent, parent2 is the outside layer. And so for actually getting in that operator, noise control 3, I needed to reference that specific layer, and then the rest works correctly. We obviously for the index just want the parent digits. Even for me, this stuff can kind of be confusing, so I'm sorry if this is coming across kind of frenetic on the video. Okay, so let's now press that. We should have a bunch of, we should have a bunch of values that we can feed in. So let's kind of play around with these values. So we could do like the different seeds. And right now what we're kind of seeing is obviously everything's multiplied together in this comp. So let's just kind of take a look at this without that multiplication. We can see things are going a little bit bigger, but something I'd recommend as well that could kind of be fun. Let's just do an add right here. So we can see that those are starting to actually go outside the bounds. Let's flip that operation order. Something that could be really fun is really going crazy with this value. So let's go like, say like 20. So things are going way over, and I'm going to go back to multiply. So we can kind of see that we have this bleed of particles going from one area into another, which is really cool. This is the basic kind of setup for using replicators and circle packing, and I think the effect's really nice. I'm going to touch very briefly on how we can use the GLSL circle pack to give us these outputs. But something I'm also going to mention is that what we can kind of see is that as I start trying to add more and more layers to this, this quickly becomes kind of a little bit impractical. So if we add lots of replicators, first off, we're limited to 100 by default. So in our replicator component, we have this maximum operators number value, and it's by default set to 100. You can extend it or reduce it. But what I'm going to do is I want to build in a sort of built-in limit here. So obviously we're taking this number value, and let's just see if I kind of go up with how many I create. I've got 261 different circles, and we can see that my frame rate has kind of tanked a little bit. It's gone down to like 40. Let's see if I add more. Let's see if I kind of go for 500. Let's see how many I can get in there. And it's not terrible, but we can sort of even it out by limiting the number of circles that we actually have. And so obviously in this case, we're only generating 100. If I wanted to generate the full number, let's kind of go to my replicator. Let's go 211. That's kind of a cool effect, but it is also running at 24 FPS, so it is kind of slow. So what I would recommend is, unless you want to work on something that's a bit more dense and detailed like this, I would recommend setting in a hard limit for yourself. Obviously, you could set it here in the maximum number of operators, but I would recommend setting it also in this value that we're sending those operators, so it's basically kind of scalable. So I want to just have a clamp of 0, and I think my maximum number I want is going to be 85. And so then I don't have the problem of potentially overloading my system. And I'll play around a little bit more with that. Obviously, in this case, I'm trying to generate 500, so that's also going to add in a bit of time here. So let's go down to like 200. And let's also just stop viewing that in the background. So having something that we can actually kind of scale is going to be useful for when we go into working with our GLSL values, because what we can see here is we have way more GLSL values than we might expect. Let's kind of visualize this too. So right now, if we actually were to take these data points, we would have however many circles there that match our texture, which is quite a lot. The first things I'm going to do, I'm going to go into my GLSL. I'm going to set my width to 1, so it's going to be a square. I'm going to set my grow rate to the same. And what I'm also going to do is I'm going to set my constant to, I just want a smaller number of particles here. So I want 20 by 20. And that's still going to be quite a lot. Actually, let's match with what we have before. So do 10 by 10. Then that should match with the maximum number of particles that we are allowed. And so what I'm going to do is I'm going to take this and I'm going to view it as a top. We can see that we have a lot of values here. We'll even that out in a minute. And what I'm going to do is I'm going to do RGBA. I'm going to do full image and output as a single channel set. And what I'm doing that's incorrect here is I actually just want to bring out this GLSL. So I'm going to add another out, because this is a big texture, this is a small texture, so this is actually what we want to work with. Gosh, I've been doing this too long now. Let's just look at this under an info really quickly. This is what happens when you record a tutorial for like 2 hours straight. So it's 10 by 10 versus 1280 by 1280, which is very big. Okay, so let's flip that over. Let's turn it back on again. Okay, way better. What we're going to see here is when I press my 1 key and reset this, we're going to see that the B is holding our size, so our lifespan. What I'm going to do is I'm going to rename this, so we can just put it into our CPOS as X, Y, and size. X, Y, size. And let me actually just check I'm not storing anything in my alpha channel that I need to utilize. No, that's perfect. So it's just my B channel. Perfect. And I can go ahead and plug that in. And so now we've taken that data and it's matching. It's kind of going through. Let's play under this camera so we can actually see better. And we can see that we're growing these particles to match. Obviously, with this system, we could go higher in terms of the maximum number of points. So let's kind of say in our replicator, we're going to have a max of, let's do 300 and go in here. We'll set our resolution to 30 by 30. This is probably going to kill this system, but let's give it a go. Limit, let's say 300. And so now we have lots of particles moving into the screen, kind of slowly, but over time we should get more and more. Maybe what I'll do is I'm going to go in and I'm going to up this growth rate. Maybe I've just gone too high here. Oh, okay. So here I'm also limiting my values. So in my replicator, I want to go to, let's just manually do this, 300. And I can see that kills the frame rate. Let's see how we do 200. Not great. So I guess this logic of before kind of still stands. Like if we keep it about like 80-ish, it's going to be pretty good. So that just means that we have to just make sure that our texture kind of is something in that range. So let's just do like 8 by 10. And then it should be more scalable. Okay, I will be editing this and uploading some files to my Patreon. I hope this has been useful. I know it kind of got a bit messy, but I think there's some interesting stuff here. And I will be making some more tutorials soon. And until then, see you soon.